So decimals are a system of recording without denominators. So we've had the guiding text shown in navy blue in the middle here of tens, ones, a decimal point, tenths, hundredths and thousandths. But we could also show this as just wholes instead of singling out tens and ones, a decimal place, and then everything after as fractions with denominators as tenths, hundredths or thousandths. For convenience, let's switch back to ones and tens, and let's imagine that this red noted section at the bottom is an invisible guideline that sits underneath every decimal that we ever write. So we can actually imagine that the word tens and ones is underneath whole numbers whenever we write them. And we can imagine that there's a denominator of 10 showing that it's tenths underneath every decimal that is directly to the right of a decimal point, as well as the denominator of hundred for hundredths and thousand for thousandths under each digit that appears further along the line. So this can really help us, and I often remind students of this and even get them to write the denominator and show the denominator underneath each decimal placing as they're learning and familiarizing themselves with fractions. So let's look at an example here with 68.149. So again, this can be confusing if we read it just as digits, so let's read it more fully as 68 and 1/10, 400ths and 9 thousandths. When we read that green number properly, it helps solidify the understanding of what exactly we're dealing with. So again, we can, in red, pretend that this is always underneath, so we can imagine it, and it will help us understand and recognize what each digit actually represents and what the number actually means when dealing with a decimal. So why do we bother with this? I'm going to step you through some simple examples, and then you'll see why having a decimal is really handy and useful to do maths with. So let's do a simple example just dealing with the whole numbers, something we're familiar with. So if I had 68, as I do in this number of 68.149, and I added 2 or 2 ones, that would create 10 ones in the ones column. And as we already have learned, we can't put a 10 in the ones column because it would make the number look like 610. Instead, we know from our knowledge that anytime we make 10 of any unit or any section of a number, we must build or create the next place value position or the next type of number along. In this case, I've got 10 ones, so I'm forced to build a 10. And I add that 10 to my 6 tens to create 7 tens. As a result, I've used up all my ones, so I don't have any ones left. So it becomes 70, having started as 68 before I added. Now this is all very well and good, but what does it have to do with decimals? Well, decimals behave exactly the same way with the fractions that we're dealing with on the right of the decimal placing. So here, let's pretend I'm adding 9/10 to 70.149, or you might call it I'm adding 0.9. If I add 9/10 to 1/10, I'm going to get 10/10. 10/10 is exactly the same as 1 whole. So I'm actually not able to put 10/10 in that tenths position to the right of the decimal placing. I must add 1. So it becomes 70 into 71. I've used up all my tenths, so now I have 0 tenths sitting in my tenths position. Let's have a look at another example. If I'm adding 1,000th, I can clearly see in 71.049 that I have 9 thousandths. If I add 1,000th to that, I'm going to have 10 thousandths. If I convert 10 thousandth into the equivalent fraction that it actually is, it will create 1/100th. 1/100th added to 71.049 would become 71.05, but it won't be 9 anymore because I've used those 9 thousandths in the adding. It'll become 0 in that position. because I've done 9 thousandths plus 1 thousandths equals 100th and added those into my 100th column. Again, let's look at one final place value position. If I add 5 hundredths, here I've already got 5 hundredths sitting in 71.050. So if I add another 5 hundredths, I can't put 10 hundredths in that position because it would look like 71.0100, which is getting smaller than 71.050. Instead, my 5 hundredths plus the 5 hundredths I already have will give me 10 hundredths, which is exactly the same as 1/10. So I'd add my 10th and I would have used up all my hundredths, resulting in 71.050 becoming 71.1. Now, I would obviously get rid of the zeros on the end because 71.1 still shows me that I have 7 tens, 1 1, and 1/10. I can get rid of my guiding notes in red down the bottom that reminds me of what each place value position represents, as well as removing the text from the top. And I can now move forward understanding decimals, but always referring back to what each digit represents in a decimal number.